All right, welcome to the Naked Dialogue podcast. We have Professor Lee Cronin with us today. How are you doing in
I'm
general?
good, thank you. And how are you?
Doing fine, doing fine. I was wondering, so you described like one of the ways or reasons for origin of life as having this intelligent design, which has, let's say, direct or indirect mechanisms, which might also, involve this metaphysical identity of or image of God. And in one of Carl Jung's very famous televised interviews with John Freeman, he said the quote, "I don't need to believe, I know that there is a God." And it was very much critiqued by a lot of people in the psychoanalytical circle and the philosophical circle. And even Richard Dawkins said that it's Jung's blind faith. But later on, Jung corrected it in one of his letters to the press and also to John Freeman, that in fact he was just pointing out to this subjective image of God, and that he also claims that the truth of quote unquote God is complex. And I was wondering, like another way of describing, let's say, the origin of life within the origins of life that you modeled is the emergence of chemical complexity. So how would you, let's say, distinguish this metaphysical complexity of emergence of God or the truth about God with the chemical complexity of emergence of life?
So you're asking the easy questions today. Okay, so look, so I'll start by saying that I don't believe in God. I've never believed in God. But I've always been fascinated with existence. But the problem with belief, it becomes a weaponized kind of discussion. There are people that believe, people who don't. So let me just tell you my very simple, simplistic, probably philosophically flawed objective with belief and science is that here is belief and here is science, and they get they're really close, but they never touch. As soon as belief touches science or science touches belief, you get confused, because what we try and attempt to do in the scientific process is to think about explanations which are consistent, formalizable, and understandable in the physical world, right? Whereas belief, when you believe something is possible, you can't always necessarily explain why. In fact, there are many beliefs that become scientific because we believe there's a genetic basis for hereditary. I'm sure Mendelian genetics was a proof of that kind of direction. I think then when people like, say, Dawkins and Freeman have a discussion, Dawkins is taking an ideological position about whether God is good in culture, and I don't really know whether it's above my pay grade. But all I would say is that I don't believe in God, but I believe there are mysteries that I want to solve. And I think the process of taking a mystery that maybe requires belief and bring it into the region where it can be explanatory, predictive, and consistent, not just falsifiable. In fact, falsifiable as a small component is where I want to be. And so what I'm fascinated with is I've got some contradictions in my mind around, how does chemistry turn into biology? What was the orchestration? And the problem is a lot of my work is looking at the quantification of orchestration. And you can say, and maybe you have questions to come to that about, you say there's a conductor and the conductor is therefore God. And I'm like, no, actually, I'm saying conductor emerges from nothing. Itself may say, so does God make itself? And I'm like, well, if you call God the ability to evolve and select, then sure, the universe can make its own God. But the traditional view of God in our culture is kind of like is to govern and organize cultures and myth, because we don't have the tools of rationality. And so I think we're mixing up. I think the old God is gone, but the new God, which is meaning, should be here, because we need meaning. God used to be meaning through control or something like that. You need to control people, you need to give people certainty, you need society to function. But now technology helps society function and our economic system, and hopefully how that's going to get better. Now we just want to understand why, and it's recursive. And so I think that's a very interesting question to get into. I'm not even sure if I even answered that correctly, or if you want to dig a little bit deeper.
I think it makes a lot of sense, because I think what Jung was trying to point was that he has this subjective image of God. He feels as if there is a God, but he doesn't know. But he also states in that letter that there is mystery, that God is always a mystery, and the mystery is complex. And we have to make the complexity somewhat understandable, but it's ununderstandable because we don't know whether there is a God. So even Jung was very, like this in terms of his definition of if there is a God or not, or what is the origin of life. The next question is how you have an assembly theory, and can you explain, let's say, the detection of signatures of alien life or extraterrestrial life via assembly theory?
Well, shall I start by explaining assembly theory, and what assembly theory is? So assembly theory is something that is obvious but non-obvious, in that, and I designed it over many years. In fact, I'm sure I designed assembly theory when I was a child, actually. And all I was doing when I was a child, I was obsessed with survival kits. How could I build all the technology I needed to create my life, my society, in a box? A really big box. Imagine maybe a country or a planet. And then I say, well, that's kind of big. Can I make it great efficiencies? And then I made the box smaller and smaller. And in the end, I had tools in my box, which I would use to make other tools in a survival situation, using the resources around me to make other tools, to make other devices, to make other objects. And because I had that information, I could recreate all my technology. And that would be how I would survive. And so assembly theory is a bit like that. So I'm a chemist. And what I've been thinking about one day is, it struck me that when I take a molecule, any molecule, and particularly if the molecule is low symmetry, so say it's quite messy, imagine a molecule is a bit like a modern art painting, lots of splats and paint, impressionistic. I'm not an artist, I think you can see, but let's say it's like I'm sure that you know what I mean on the art side. But let's just say now I've got this painting which is really unique. All the brush strokes I could probably only do once. I wouldn't do it again. But just imagine if I found something as complex as a really nice modern painting, art kind of rendition of something or a concept, but I found 1 million identical copies, right? 1 million identical copies of that same object. It'd be like, wow, this person really knew what they were doing. They kept making it. There's a process that made it. And if each brush stroke was different, that's really odd. So I want you to keep that in your head. But let me explain assembly theory. Assembly theory just says, given a complex object, if I take the object and I cut it into parts, so I've got my object, let's say I'm going to have the object is abracadabra, it's a word. So abracadabra has 11 letters, okay, the string length is 11, and it has letter A, B, C, D, R. Okay, so I take abracadabra and I cut it up randomly. So I can cut it into kind of, a 5 and a 6, a 4 and a 7, or whatever, a 1 and a 10. And what I do is when I cut it up, I take the product and I put it in my assembly pool. And I say, can that be cut any further? And if I do, I cut it again. And I keep cutting it down until I get all to the 5 atoms of abracadabra. And then what I do is I look for the shortest route from abracadabra to the letters. And I say, okay, how many steps? So the longest route could be 11, couldn't it? Because I cut it 1, I cut it, well, it's actually 10. So I cut it all. And the shortest route I can get there is 7. So that means, because I can make what I just add the A to the B to the R, right? And then I add an A, and then I add a D, and then I keep going on until I've got the abraca, and then I got bruh, and I add on the bruh at the end. So what assembly theory says, given an object I can break into parts I can understand, what is the shortest route I can reconstitute that object together? So it's a pathway thing. And when I kind of try to establish that, a lot of the complexity of saying, oh yeah, it's kind of like Kolmogorov compression, it's kind of like this, it's kind of like that. And I couldn't really get people to kind of help me understand whether it was a new concept or just an existing one. Now, why does it matter if it's a new and existing one? Well, if it's existing, presumably there'll be algorithms out there to borrow, and because I'm a chemist, I don't want to invent new complexity theory. I want to do chemistry. So, but it turned out that there wasn't anything out there like it. It was similar. So what I did is I developed a mathematical framework, and I did it in a kind of backwards way, but kind of a cool way. I did it with my group. I made the algorithm first to basically chop up molecules and check it worked. And then as I made the algorithm, I understood how the algorithm worked. I then was able to formalize the mathematical part of the theory. So what we can do is, let's take a molecule, let's say a simple molecule that's symmetrical. So let's take something like, I don't know, what molecule everyone would know. Yeah, there's lots of kind of complex molecules that people would know, painkillers and things, drugs and things, but not really symmetrical ones. Let's take soccer ball carbon. C60. So that's a soccer. So it's basically a molecule, or it's not quite a molecule, but it is an object made of 60 carbon atoms, and it has exactly the same shape as a football. It's basically got pentagons and hexagons. So that's a highly symmetric object. It has 60 carbon atoms in it, but if I cut it, there's lots of symmetry. That means that that molecule could basically be made in just 4 or 5 steps, putting together. Now, if I take a very powerful anti-cancer drug that is found in biology called Taxol, this molecule is kind of big. It has like over 50 atoms in it. It's not got very high symmetry. And in fact, C60 basically requires 5 steps. Taxol, that has 59 carbons and some nitrogen and some oxygen, requires 33 steps to make it probabilistically. So so the chance, if you now think you're going to walk down a street and you've got to take 33 choices, if you take 33 choices on a decision tree, very quickly the tree gets deeper and deeper and deeper and deeper and deeper to the answer, which is Taxol here. And this vast space of other objects is literally trillions and trillions and trillions. So when you find Taxol in an amount that you can detect, so many copies, and not the other trillions and trillions and trillions of examples, you have to say, how? Now, what that says is, when you can find a molecule with a high assembly number, what assembly theory says, when you find molecules with high assembly numbers, they must be made by a process that is non-random, that is somehow directed. Now, I don't mean God, I mean genomics, human beings, some selection process. So assembly theory, really put very simply, tells you about the degree of selection in the universe, but I'll put it more impactful than that. Assembly theory allows us to measure the degree of selection in the universe for any given object at any given time. And it's the first time that this has been possible. Because if you say to people, what is selection? They'll say, well, it's maybe, you know, I'm selecting a candidate for my job, or a protein is being evolved, or the market is selecting this activity over this activity. It's a very hard concept. So the reason why it became a life detection system, I designed it for this, is NASA is sending lots of mass spectrometers to Mars, Enceladus, Europa, Venus, and so on. And what a mass spectrometer can do is it records the mass of the molecule coming in, and you can fragment the molecule into lots of parts. It's a bit like you and I don't know, maybe going, let's say we go to China or to somewhere in England where they're making lots of very special plates with lots of shapes and intricate, you know, pottery. And we're like, oh, that's a nice one. We take the most unsymmetrical pottery and we hit it with a hammer, just gently, just enough to break it, not turn it to sand. And we count the number of parts. We keep breaking it and we get the simple bits. And we say, we can say how complex the pottery is because of the number of fragments. So the mass spectrometer does that to molecules. So if we can send it to, say, Mars or Venus or Enceladus or Europa and break the molecules and say, are the molecules here complicated, or do they increase in all, are they increasing in complexity? And if they are, or are they increasing in the number of assembly that I'm detecting, is there a threshold over which I would say, oh my gosh, there is no way physics can be producing that, or physics without life? So what assembly theory says is the degree of selection you have, and selection produces memory, and memory allows you to store information to control a process. And that's a very long answer, but I think it's a relatively precise answer.
No, it's extremely precise, because now I see the way assembly theory and extraterrestrial life could be detected, like if it's applied. Also, like when we try to define life, let's say via reaction networks, and or let's say energy or disorder, it seems to me as if like all the cells synergize. So like synergy would be one cell and two cell making, replicating. So 1 + 1 is 3. And so this emergence is this 3, very broadly speaking. And like when this kind of synergy and emergence happens, how can we utilize, let's say, non-carbon based material to create life? So like using inorganic biology to create or life.
So, I mean, this is a very speculative point I've made many years ago. So I'm an inorganic chemist, and I used to make a play on words. And going back in classical organic chemistry, organic chemists would differentiate between vitalism, and I have to be careful because the history books are complicated and different historians have different views of this. But put simply, the current view, which may be flawed to some degree, is that organic chemistry was viewed to be have vitalism associated with. There are certain molecules that appear to be kind of have a life force, okay, and that was in organic biology. And then there was a kind of part of carbon-based chemistry that was more inorganic with no life force. And then some chemists in Germany and the UK and France showed there was no difference between the vital molecules and the non-vital molecules, and so that all organic vitalism was really inorganic. So really the term organic now refers to chemistry based on carbon, and inorganic means non-carbon. Now, so the central question is, if we've got rid of vitalism, is it possible to make life based upon elements that don't involve carbon? And my simple answer is, I don't know, because I don't know any other types of life. But my more nuanced answer is, I don't see why life cannot be based on other elements than carbon. But our carbon, because carbon, what makes carbon good on Earth is that it can form stable molecules. It can be then recycled. It can make polymers, and it can make these long chains. But on Earth, 1 atmosphere, 25 degrees Celsius, 1 G. Let's go to another planet where the temperature is higher, the pressure is higher, the gravitational force is higher. What chemistry that can form chains? Maybe the carbon-carbon bond is not stable at that temperature. Maybe you have to have phosphorus-silicon bonds. Maybe you have to have different types of structures. And so I think that what we have to be able to do is very carefully say, look, just because life on Earth is based on one particular type of chemistry, we shouldn't fall into the trap. It's like saying, okay, let's take the classic automobile now, right? An automobile is made with 4 wheels. All cars in the universe must have 4 wheels. Well, we know it's not true. There could be 3 wheels, it could be 2 wheels, or a motorbike, it could be 10 wheels. It's just on Earth, it seems to me the most practical solution has been 4 wheels to get maximum, control and traction and whatnot. And so I think when the question is posed to me, is life possible beyond carbon? I think the answer is yes, because we don't know what are the limits of life are. But the more honest answer is we don't know, and we should go looking. And then it exposes a more fundamental question to say, well, what is life in the first place? So this is a cool thing, right? It's like, can you get selection in non-carbon based systems? And the answer is yes. In fact, I showed it a few years ago. I published a paper where I showed how molecules made of metal combined with oxygen, we call them oxides, can assemble themselves into very complex structures. But more importantly, they could self-replicate, they could copy each other. And they could do it in a network. So you had a small molecule that was able to make a bigger molecule, that was able to make a bigger molecule. And then that big molecule was also able to help make more of the small molecule. So you had this network of molecules making one another. And that, for me, showed the process of selection through replication and copying can happen beyond carbon. And that's where I am at the moment. I'm excited about that. And I think that we should just make sure that we don't close ourselves off when we look for life, because life on Earth, biology on Earth, I am pretty sure is unique to Earth. Now, that doesn't mean there isn't other life like us in the universe, but I very much doubt it. What we might be able to say is, like, how common is the rocky planet type of Earth? How common is the kind of temperature, pressure, gravity, and solar flux, and elemental composition? And then say, given those proto conditions, if we were to run the clock forward, how many different life forms could we imagine getting? Or how many different chemistries for life could we get? And I think it would be absolutely mind-blowing to consider how that would go. So I think it's a very open question. There's certainly no reason, scientific reason given to me, that prevents life going beyond carbon. And also, it's rather simplistic to say life is based on carbon. It's not. It's based on carbon, hydrogen, oxygen, nitrogen, sulfur, chlorine. There's some chlorine. There is iron, copper, nickel, molybdenum, tungsten. All these elements are vital for biology. And I've probably missed some out as well. Some people might argue that even fluorine is in there, but I think fluorine and silicon do not natively occur. Oh, and phosphorus. No phosphorus, no DNA. And so there's lots of elements that are needed for life, and they all have different roles.
No, that's definitely very interesting, because I'm not a chemistry student, but like when I try to imagine these things come into like play, it seems very structured to me. Also, like if the driving force of evolution is, the survival of the fittest, as you describe it, so molecular Darwinianism. How would you distinguish between, let's say, the living world from an inorganic living world?
Assembly. I think this is the thing I've realized, is that actually, in kind of weird things, that life doesn't really exist. It's like kind of weird, right? Life doesn't exist, consciousness. So you asked me on one day when I'm very flat materialist, ultra materialist. I mean, there's no difference between me and the sand in my garden or on the beach. Still, it's just atoms. So what I was like, well, hang on, that's clearly not appropriate. What do I do? Well, let's say, well, hang on, I obey the laws of physics. So what I'm going to do is I'm going to give a really long answer. I want to go all the way back to the Big Bang, to physics, because what I think is happening is that that physics and chemistry and biology are really the same discipline, but we're thinking about it all wrong. Physicists think they're so, well, no, I'm not. Physicists are very pure in terms of they're looking at very well-defined systems to start with. They would argue they get to complexity, and that's true, but they like laws. So there's laws about the forces in the universe. So we have gravity, electromagnetism, strong nuclear force, weak nuclear force, and maybe a fifth force that may be associated with time, with axions, with dark matter, dark energy, or just we haven't got the structure of the universe right. There's something wrong because we have to unify relativity and quantum mechanics, or we don't, right? It's like a bit like the wave particle duality. I have no problem thinking like a photon as a particle and interacting like a wave. They don't have to be different. But anyway, let's go all the way back. So you've got physics. Physicists say there are laws. Well, what is a law? Let's think about what is a law. Well, let's just take the inverse square law for gravity. So the inverse square law for gravity says the force between two objects, two masses, is a function of the two masses, the product of the two masses, divided by the square of the distance between the two masses. That's a law. The thing about saying, who says it's a law, right? If I go to the other end of the universe, like let's say 20 light years away, where I can't go, hello, there's a law, don't forget the law. How does the universe know to react like that? So a law is a simplistic thing to say, actually, when the universe has low memory, low assembly, there's only a finite number of positions, configurations, matter, and energy can get into. And they fall into these categories, being able to produce gravity, electromagnetism, What I'm saying is relatively obvious, but at the same time heretical. I'm saying there are no laws, there's just low memory. So when there's low memory, the same thing can happen everywhere. Okay? So that's really important. So that's physics. Big Bang physics done. Now let's go on and say, right, now we're going to form planets. Well, we're going to form stars. There's the start of chemistry. The stars will explode, give planets. On those planets, we have heavier elements, more electrons, more things. When you have electrons and elements and things that can operate in atoms, you can get bonds. And when you can get bonds, you start to get a combinatorial explosion, because this atom can bond to this atom, bond to this atom. You get really weird shapes. They can start to make shapes. And the universe, and those shapes can be randomly made, if you like. They're directed, but the universe is deterministic, but there's a lot that can happen. So what happens is that locally, the exact pattern, if you view the Earth like an art exhibit, the artist that is planet Earth has got all their experience from the creation of Earth in our solar system, the mass coming into Earth, the accretion, the big asteroids that came in, the boiling of the oceans, the formation of the oceans, all these steps go through. All these events are individual, unique events, and they give chemistry on Earth its unique signature. So now we've gone from physics to a rock that's unique because of chemistry. Now what happens is there's another combinatorial explosion in organic chemistry on Earth that seems to then lead to biology, and biology then creates cells through selection. Selection's occurring all the entire time. So what I'm trying to say is selection is the power in the universe that drives the universe forward and is quantified by assembly. The assembly number of quarks and electrons is low. The assembly number of, and that's with regard to the memory, not the number of configurations or amount of stuff. So when you get more memory, you can break the law. Or no, you don't break the law, you make local laws. So on Earth, we can make a local law to say, well, I can make DNA. So I use the low laws of physics, that give me for free everywhere in the universe. But on Earth, because I have phosphorus, oxygen, carbon, and these selection and these minerals, I can make DNA. And once I've learned how to make DNA through replication, the entire planet is making DNA. So that's almost like a new law that's local to Earth. And so because now selection becomes more and more kind of contingent upon these events that have happened in the past, the craziness of the objects we get goes up, because the assembly number now isn't just in the object, it's in the history, the billions of years of history. So what am I saying happens on Earth? The selection occurs right from the sand through to chemistry, mineralogy, but selection gets hyper accelerated by biology. So we then basically are able to change more configurations. And what living stuff is able to do is take advantage of that. Okay, I went back and said, I'm not really alive, I'm just an object. Well, of course, I have some interesting properties we don't understand yet as a living object. I can make decisions, I have causal power. And this is one of the biggest things that we don't understand. In assembly theory can kind of tell you when a system has causal power or not. And I think that assembly theory, or the assembliness of a box of objects, will be a more important number to calculate than the entropy, because entropy tells you about the amount of disorder than the number of configurations, where assembly says something more about what was the amount of memory required over time to build this object. And they do two different things. So I think selection operates over the universe and life emerges and accelerates selection, but the driving force in the universe is to basically persist. Those objects that persist or exist are able to cause other objects that didn't exist before. And human beings are just wonderful versions of that, because in our minds, we can create objects that don't exist yet in the real world in our mind as an abstraction, and then we can go build them, such as, I don't know, this 3D printed tesseract, which I went and designed and then made on my 3D printer, right? I can think of it in my head, and then I go and actually drew it and make it.
So, like, would you say that there is some sort of imaginative capacity within humans, which leads to this kind of abstraction of creating objects within our mind? And then somehow, with the use of 3D printers, we can maybe replicate these objects.
Yeah, I mean, I think for me, the understanding how the universe is able to build objects that are able to abstract and build other objects that were no longer possible, or sorry, not before possible, is amazing. You think about it, you have all this dead stuff in the universe, you have life, and then life is able to then, at the human being level, I mean, maybe some animals can as well. Let's just say living systems, intelligent living systems, suddenly can think of things and then can go and act differently on stuff to make abstractions. And then if I give this to my child or to someone else, they might actually build on the abstraction and build another thing. And we keep going. And so there is this really interesting zone that humanity is in right now, whereas we are creating abstractions upon abstractions upon abstractions. I mean, some of the first abstractions, I guess, were in language and money and legal systems, right? But I mean, it doesn't stop there. And one of the biggest questions I have about is, and I argue with a lot of computational scientists, right, about whether, because they think that, but maybe you'll get to this later, about consciousness and computation and living systems, like what are we really talking about? But what I think is, but just to finish this part of the conversation, I think it's very interesting that selection gives rise to biology, and biology is able to create more objects which aid selection through abstraction. And the imagination that you have, when you think of an object in your head, it exists, but only in your head. And then if you're able to then create that object in reality, it seems that object, when you create it, has more causal power, because other people then see the object and went, oh, you meant a tesseract, you didn't mean something else. Okay, I can see that now. It's a bit like integers, or coming up with zero. Like, it took thousands of years to come up with the concept of zero, but now we can't forget about it. It's the most fundamental abstractions and contagious. We just give it to everybody and say, think about zero, as well as just what you have, think about what you don't have, think about the null set. And that's just a mind-blowing process.
Yeah, so you laid out like the recipe to create, let's say, the inorganic life. So with metabolism, information, and then containers, to, let's say, mimic life, or to maybe simulate life. So, in the AI project, maybe broadly speaking, if people are trying to simulate life into machines, one can say that within biology, this recipe could mimic life. So I see both the projects having some sort of the same goal, which is to make life or to give sentience. So how would you distinguish or even say that there are similarities between, let's say, the AI project or the computational project with the chemistry and the biological project?
Yeah, I mean, okay, that's a big question. So there's a number of assumptions there. I mean, I'm a materialist and I'm also a computationalist, and I believe the universe, or I can use mathematics to help me describe the universe, describe my explanation of the universe. But what I'm very trying to put down in really concrete terms, that mathematics doesn't explain the universe. Mathematics allows me to describe the universe so that I can explain it with other stuff. And what seems to have happened a little bit is people have basically taken mathematics abstraction away from the universe and then used that to build objects that they say really describe and cause the universe. And I think that that's a beginning of a kind of dualism, actually, although they will violently deny this. And so the question I have, you were talking about, say, making life, you need all these objects. I don't know what you need to make life. I know that you need selection, and selection on Earth, the solution seems to produce a metabolism compartment and all this stuff. But why can't we make a single molecule life form? I said to my research group a few years ago, they're like, what? It's like a single molecule life form. Just imagine a big enough molecule that could do things to itself and be in. They said, no, insane. I said, probably you're right. But so we don't actually know what are the requirements for life. But there are some requirements, and I think what you characterize it as is useful because it helps you think compartments, energy, and so on. Now going on to AI, the thing about AI is the way that AIs are built right now is they're based upon a digital abstraction, as far as I kind of understand it. And those different abstractions are instantiated in silicon. And so my number one concern is that the way that we build architectures on silicon are based on digital, high-low. Then we make Boolean operators, Boolean gates, and then make logical kind of operators, and then put them together to make logic and go all the way up to an operating system. Then in that operating system, we do fancy other things, array manipulation, inference engines, and so on. And we're trying to use those inference engines to tell us something about consciousness. But look, how you think about that, we've gone from a transistor, high and low, through Boolean logic, all the way up to an inference engine and consciousness. But the brain isn't made out of transistors. The brain's made out of unknown computing processes, computing modules. They may be neurons, they may be glial cells, they may be some interaction, but where do we actually know what is going on in our brain on any level? I don't think so. And so we understand some stuff, but because we don't understand, and people say, but hang on a second, you know, do you believe, are you a materialist? And I say, yes. And say, well, do you believe the brain can be simulated in computers? And I say, to some degree. So, well, there's no problem, just extrapolate and we have an AI. And I think that there is a very practical argument against that, and that's a resource argument, as to say that the reason why I'm interested to talk to, and you're interested to talk to, is you have I don't know what the exact number, 100 million trillion neurons in your brain, and each neuron has 10,000 connections, and those connections can change. So at any one time, you have more connections, possible connections in your brain than there are atoms in the universe. Now, if you now take silicon, 2D, transistors on a die, we can do pretty well, put 10 billion transistors on a die, and we can make software layers that can wire them up in fancy ways, and we can make parallel systems, but we still have nowhere near the search space of a brain in any hardware architecture. And we don't actually know how that information is represented in the brain. And I think, so there are fundamental levels, like, where is the information represented? How does the morphology control it? How much of our thought processes and our understanding of the universe, how much has that been built by morphological evolution over billions of years, as the universe has used trial and error to build a brain? And I'm guessing that my brain is a 5 or 6 dimensional organ. So I have the dimension of evolution. I have the experience of evolving in all the environments on Earth, trial and error. Okay, that's one. I was also developed in the womb and grew, so my brain structure was built. That's 2. I'm able to move around in the real world and think in real time. That's 3. I'm able to imagine things that can happen. That's 4. I'm able to have imagined conversation or have conversations across whole networks of people. That's 5. I can then also outsource some of my discussions to some kind of silicon AI. And so I have that 6. So I have at least 6 dimensions of a way of understanding how I'm creating my intelligence, thoughts, consciousness, whatever. And I just think that we know so little that we're making assumptions, and we are deluded by the digital representation. And I'm not saying it's wrong. I'm just not saying that anyone has shown me with any confidence that we're going to be able to make a machine based on the current understanding of technology that can have the type of common sense, cross-domain thoughts, thinking about, my dream is to talk to a machine that we both have the same question. And do you want to guess what that question is?
I don't know. You tell me.
I think you could, but I'd say, why are we here? So if we can create a machine that goes, why are we here? Oh my God, this is a bit weird. And genuinely evidence they're having that thought, then I know we'll have created a consciousness. So forget the Turing test for imitation. Let's go for the Cronin test of why are we here? So really, you want to be able to make a thinking machine that asks, why on earth do we exist? That, if you can make a digital philosopher, then yeah, sure. Then we want to, because we'd talk to them all the time. We'd probably never leave our rooms, right? We'd probably just always having conversations, and it'd be infinitely fun. Like we all talk to each other about these questions, but sometimes we get stuck. But maybe the AI will have a better kind of symbolic representation, more robust logic, and will be able to take us deeper into thinking about what the nature of reality really is like. I didn't really answer your question, but I really wanted to get to the point that I just think we don't know what consciousness is on any level. And I think that doesn't mean we're not going to. I mean, for me now, if I was going to be I always want to be a scientist. I'll change career many times, but understanding how the brain works, being, a neuroscientist, or I would like to be an evolutionary chemical neuroscientist with bent and computation. That would be the place to work, because there are so many interesting questions there. But I have to solve what is the origin of life, and can we make life, before I get on to the origin of consciousness, and can we make consciousness? But it's on my to-do list, but I guess the origin of consciousness and consciousness might be on your to-do list as well.
Yes, it seems very interesting, because if, let's say, mathematics is trying to describe life, and then biology is trying to define it. And so what would be the philosophical project? Because you're right, like, even if we ask the machine, it's going to ask, oh, what is ontology? Like, why are we here? And so it seems very interesting. Like, one of the ways I was thinking to solve like this big question of qualia, but taking, like, let's say, a multidisciplinary route, is to somehow take psychology, philosophy, but also neuroscience and computation, and take out all the theories and like use some sort of a top-down reduction of all of these theories to answer this question of qualia, which everyone seems to be arguing about. And one of the ways which seems kind of popular today is that people think it can be defined, or it can be assumed that it's like the sensory modality of perception is somehow a way of describing what qualia is. So if we are perceiving an object, philosophers would say is the imaginative capacity which renders the image of objects around us. So we're actually not seeing the way this glass might actually be. This glass has its own external material reality. It's only our imagination and perception which thinks that this glass has these kind of texture and shape and color. So it seems very interesting when we talk about consciousness and like how we can describe this hard problem of consciousness. Do you think there's any theory, either from the computational side, psychological, philosophical, that seems to you as the most accurate, or probably the most possible way of kind of deciphering this qualia question of hard problem of consciousness?
Yes. Although I like to argue with experts in AI, I'm having some discussions. Well, I'm discussing a lot with Yasha Bach and also Sarah Walker, and I have sympathy with all the points of view. I must say, I'll not take sides, but Sarah and I are working closely together on how to build, how to understand meaning in the universe, right? But I think that Yasha's view, or understand the way he picks it apart and thinks about it in this very mathematically and conceptually precise way, is really useful, because what it forces us to do is to say, well, look, can we in principle capture, if we're to understand all the basis of our current abstractions of computation, could we capture consciousness? And there doesn't seem any reason why we cannot. But what I'm wanting to know is what is yet missing. Are there things sub-computational? Now, what I mean by subcomputation, I don't mean magic. I mean, are there physical things going on that we have not yet understood in terms of the correct abstraction level? And are there processes that actually are not really amenable to abstraction yet? And if not, why not? And I think actually we can see there's a gap. So there's a problem, but I don't think is what I thought it was with computation. I think computation is probably okay. And that we're going to get to consciousness or some elements of consciousness in computation. But what we don't understand is this whole idea that the process of the simulation, or the process of, are we living in a simulation? Are we able to make a consciousness in silicon? Are we able to basically understand take your consciousnness from your brain and put it into another object? I mean, I think that's actually an easy question first. Could you download your brain? No. Oh, why is that? Because I'm special, not physical? No, because because your consciousness is so embedded in your physical morphology, the way your neurons have grown, to take you and put you in an artificial you would be impossible, because the only way to create you was through 4 billion years of evolution, progress in the womb, education, and now. And so you just can't undo that. It's not as simple as that. And people will say, well, wow, but look, if I could read every electron and everything in the brain and recreate it precisely, I would have you. Sure, you would, but you cannot do that. It's a practical limitation. And I think what I've been focusing a lot on as a chemist, actually, I understand those practical limitations. And what I kind of maybe am trying to push on with the computational version, say, where are those practical limitations? Can they help us get to a deeper insight? Is the practical limitation just, we'll just get better? Like, if we get better at moving atoms around, one day we'll be able to download your brain. Is it like an insurmountable barrier? So I think there's really interesting things there about, like, where I'm a materialist. I believe that the brain should be able to be understood by physical science, by mechanism. Are our current computational paradigms powerful enough to understand the brain? I think the answer is no. And that's where I think I'm realizing that there is a small gap which would keep me talking to both people and be productive. And so the question is, what do we need to do to our current computational paradigm to make it more powerful, so we can? And then people might say, but what's more powerful than Turing machine? And then I would say, well, let's go back at the assumptions of the Turing machine and understand how that appeared. And so I think, that's a very long research project. And it's to answer the question, like saying, could we just do a synthesis and go, top down? The problem with doing the synthesis across all these fields is the classic interdisciplinary problem, is that superficially people use different words to describe the same things, but then think they are different things and then get more complex for no reason. So there's additional complexity. And so what you've got to almost do is get these people from these perspectives together and almost lock them in a room until they are able to build a boat or a pizza or a computer, so they actually understand each other. And I think that's going to happen in terms of, we're going to have to take the disciplines down, aren't we? Not just the disciplines of chemistry, biology, and physics, but also the disciplines of psychology, social science, and philosophy. But then what we're going to have to do is give everyone modules. Give you a logic module, give you an epistemic module, give you a statistics module, give you a chemistry module. And all these modules have to be taught in such a way that they share a same abstraction level. Again, it's probably not the perfect answer to your question. I don't think we're going to be able to answer what consciousness is yet. I'm not even sure that consciousness exists in the way that we think it exists, but I definitely think I'm talking to you right now. You've fooled me. If you're an android, you've done a brilliant job. And I'm trying to fool you as well if I'm an android. So I'm pretty sure that I'm able to take in information, build abstractions in my head, think about those, and then give you answers back. And maybe that's what people mean by consciousness. But I don't know is consciousness is something that exists in the substrate. It doesn't exist independent of it. And I think that's maybe the problem that computationists don't like. They're so used to loading in a program into silicon and the silicon just operating differently. I don't think because of the way we made hardware and software different in our society and our technology, I don't think that applies to the human brain and consciousness. You can't divorce the software and the hardware. They're too intrinsically entwined.
Yeah, that's very true. I often like this entire field of panpsychism, which is like consciousness is everywhere. It also kind of stems back from this old Egyptian Hermes Trismegistus, who wrote this thing called the Kabbalion. And one of the first Hermetic principle in that is that the all is mind. So kind of pointing out to that the consciousness is everywhere, which seems like a very ridiculous idea to me, at least. But it's popular. It's a popular opinion. So yes, you're correct in saying that this consciousness is always going to remain a mystery, and we're always going to be making assumptions. And so one of the things that will end up happening is that we'll be believing instead of stating a fact that, oh, this is consciousness. I watched one of your TED talks about the idea of printing medicine, and it was very, very interesting to me, via molecular assembly. So I was wondering whether you can describe the entire process again, because it's very, very interesting to be able to print your own medicine.
Okay, well, that's a big question. So one of the things I'm doing a lot in my career at the moment is like, the origin of life. I think I need to break the computational paradigm some way to get origin of life and consciousness ultimately. But because I looked at the computational paradigm so carefully, I realized there's a chemist, I'm not using the true power of computation. And as at the abstraction level, I don't mean computation as in a calculator or solving numerical problems. I mean the abstraction to do chemistry. And so I came up with the idea a few years ago now to basically use a 3D printer to basically 3D print test tubes to do chemistry in them. And lots of people got confused because they think, oh, I can make an atomic arm that's going to move atoms around. No, I don't mean that, because chemistry happens by collisions and moving stuff probabilistically. Could I 3D print a test tube? So, 3D print that. And then could I use the same head to move chemicals into the test tube in 3D control and then do the reaction? Why do I want to do that? Well, because I have control that I don't have over a human being. Human being might drop the test tube. They may add the things in the wrong order. So I thought, would it be cool if I had a state machine where I could very concretely move objects around and have a audit trail for them and use that to do chemistry, and then basically think about that as a library or a module or that I could then give and say, right, here's a module for making ibuprofen, which is a medicine, or here's a module for making a type of acid or a base or a fuel or something. And I think that that's where I started in the 3D printing, right? That kind of, and then when I gave that TED talk, I think it was like just a few minutes, I went back to my group and went, it's kind of a cool idea. We should really do this. So, and we did it. We did it within 6 months I already had the plans. And the idea is we took a 3D printer, a standard cheap $200 3D printer. They're cheaper now. And it printed a test tube in polypropylene, which is a chemically resistant plastic. We made some pumps and some valves, some syringes, and we moved some chemicals into there. And we used the 3D printer kind of plate as a shaker and a heater. And we made ibuprofen. So we made a medicine. And then I was able to give people a file, a digital file, like run this code and you can make the drug. And people were like, whoa, that's cool. You can run a code and make a molecule. Are you 3D printing the molecule? No, I'm not 3D printing the molecule, but I'm using the 3D printer to print the architecture that controls this chemistry. So it's about an abstraction above, right? So I just added on an abstraction layer. And then moving on from that, I made a thing called the computer, which is kind of like built on that. And the computer is a state machine for chemical synthesis that basically, if you put code into the computer and you put basic raw ingredients, it will run the computation and the output will be the molecule that you want. And it will do it on demand reliably every time. And that was a dream in my head. And it's taken me maybe, I don't know, probably between 5 and 9 years, depending where you say I started. So I started doing 3D printing chemistry in 2010, 2011. I started moving over to computing in 2012, 13, 14. And then the first working computer, which could turn code into drugs, was in about 2017, 18. And what we're doing now is just establishing the programming language for chemistry and really establishing the paradigm going forward. So the whole idea is not to 3D print the molecule, but to organize the materials such that they are in the right place at the right time to do the right chemistry, and it's pre-validated, and that we understand what could go wrong and what can go right so we can make it reliable. And that's really important, because then it's almost like, if you were going to use Python to solve some complex mathematical operation, you could write yourself a library, but you could just use SciPy. And so it's like, and SciPy would understand what you're asking it to do, and it would do all this cool stuff, and it would work it out. So in a way, the computer is kind of like an add-on for a bench chemist to basically outsource some boring stuff or dangerous stuff or repetitive stuff. So it could be done in this without too much effort, but reliably. And so that's how that idea got born. And it was kind of interesting, because originally I wanted to build these engines because I needed enough accessible robotics to do a search of chemical space to find the origin of life. So I designed the whole abstraction of computation to try and fulfill my desire to build a technology which allowed me to do many reactions to find how life got started on Earth.
That's extremely, extremely interesting, because to make it even more abstract, like there's a lot of talks going around psychedelics nowadays. It's getting legalized. People are using it for depression, anxiety, and all of these psychopathologies. I was wondering, because like Alexander Shulgin, who was a very famous psychoactive chemist, let's say, synthesized a bunch of drugs, let's say, so 2CB and DOM and stuff like that. Is it possible, maybe, like looking at this idea, to like 3D print architecture for new psychoactive substances? Or is it something about psychoactive substances which is very bizarre or different, that it's almost like another science in its own way?
No, you can make, to put simply, any molecule that a human being can make, you can make in our systems. I'm not sure whether you'd want to, and I'm also not sure that you would want to make a molecule that you then ingest, because what if something has gone wrong, it's impure, you could poison yourself. So there's kind of the health issues. There's also societal issues. I mean, if you could, in principle, you could 3D print, well, not 3D print, you could use a computer to make crystal meth. But hang on, before we all get excited, you could also go and use a test tube to make crystal meth, right? It's just, you're still doing it. The intention is there. Does it make it easier for people? Potentially, but when you're talking about making drugs, you have to be really very careful in that the drug companies are regulated and do things to a very, very high precision for a reason, because they need to assure patient safety. I mean, think about what's been going on with COVID and all the disinformation about vaccines and microchips and side effects and understanding risk. And I think one of the good things that's going to come out of COVID-19 will be an appreciation that let's not get scared and take a side. Let's ask ourselves, what is the risk? And let's think about the risk in populations, right? There's kind of, I say to my research group every now and then, there's a kind of joke, we evolve together, you die alone. And what I'm trying to mean by that is not to be nasty or kind of fatalistic, say, we evolve as a group of people. So it's easy to think about statistics over a large number of people. But of course, when something is happening to you, it's very personal to you. You are no longer statistic. So you're no longer intellectually able to make that disconnection. Coming to the robots, can you make psychedelics? Sure, you can make them. But I think society has to ask itself, do we want to allow technologies where people can make psychedelics? Let's say they could make them safely on demand. Do we want people to have access to them? I think in the end, probably yes. We'd probably give people certificates, a bit like you say you have a license to take it, or maybe a prescription, maybe you are depressed. But I think one of the big problems, rather than making our own psychedelics for legal use, is the fact that psychedelics are incredibly important to understand consciousness, because they are really interesting levers. And the fact that we don't allow our society to use them or discuss them even, and yet we use these current therapies, lithium therapies and other antidepressants that just don't work, where basically a few big doses of psilocybin can actually, I mean, not cure depression, but there's enough data out there to suggest that it is worth taking very seriously to think about how we can look at decreasing human suffering through the use of psychedelics. But again, it's beyond my pay grade. My job is to make sure the technology, the science happens. My job is also to make sure the technology can happen. But my job is also to make sure that people understand the consequences, and then policymakers and government and society can decide. My job is not just to push it out there and allow everyone to get high, Rick and Morty style.
Yes, true. I think there's a lot of ethical implications at the moment for such an idea to come about. Also, one of the things when people take psychedelics, they try to explain is that everything makes sense. That's one of the maybe effects, loosely speaking. And oftentimes people would also subjectively describe ascending to these higher dimensions within your mind. And I was wondering, how there's in theoretical physics, there's like 26 bosonic dimension theories and all those kind of different theories, and then people also talk about like taking psychedelics, and somehow the mind is the controller, and the mind makes you go into all these different dimensions. What do you think exactly is happening with psychoactive substance? Like, what kind of chemistry is going on in there that people actually believe, and some people actually then think that belief is a fact, that they are, that everything makes sense and that they're transcending into dimensions?
Yeah, I think the problem with psychedelics is this whole idea that suddenly we're transcending and we're having some spiritual experience, and the fact is we're just atoms, right? And we're atoms, and we are integrating information, and we're trying to understand how we work in that reality of atoms. So if I'm going to be pour cold water on it, I mean, I'm sure if I could take psychoactive substances legally and safely and dial up different conscious experiences, I do it. Why the hell not? Be hilarious, right? But actually, I think I already have a mind that's fairly trippy, so I need to be careful. But what do I think is happening? Well, I think the brain is actually there are people, experts in AI and psychology and neuroscience, are really beginning to understand the brain is not just one single entity. There's lots of different things going on. There seems to be a consensus going on in the brain. There's lots of thought centers, right? So it's almost like your brain is some kind of, I'm not saying this is a proven model of consciousness. We don't really know very much, and I don't know enough of the literature, but there is some emerging suggestions that your brain basically does consensus-based thinking. So basically you're always you're in a war with yourself. Certain processes are being dumbed down, others are being heightened. And when you take psychedelics, what it does is it basically removes a lot of the abstraction baggage. So you stop worrying about the past. You stop conceptualizing about what's going to happen next. You just exist in the present. And your sensory, the way the senses are manipulated, or you start to basically, you see yourself dissolve, right? So you're the agent that requires to integrate who you are, your memories, with your desires, what you want to happen next, and what's going on around you. It's basically just said, hey, calm down, just exist. And so when you remove that noise of and I'm using the words really badly, but I'm sure people who are professional or interested in this, listening to this, will know what I mean, is that dampening down allows you to exist in the environment and pay attention. And then also, often people say that, they realize there's an artificial boundary that your ego gives you to protect you. That is really an artificial boundary. There's no difference between this 3D printed object, the atoms in here, right? Except that obviously my system can, maintain my fingers and keep them alive so I can move them. Whereas this thing is kind of, separated to me. So I have a different attachment to it. But by taking psychoactive substances, you kind of, that barrier gets dissolved. Are people seeing higher dimensions? No. That we might be able to think higher dimensionally because maybe there is some feature of reality that those higher dimensions exist in some evolutionary way, or they kind of are packed in there. But I don't think they're seeing higher dimensions necessarily. But I mean, I don't know. If someone takes psychoactive substances and comes back and says, I've now got a new theory for storing data, and I can store data in 6 dimensions where there are only 3, and shows me, I'll be like, hey, cool. But that hasn't happened, right? It's a lot of kind of, it was really good, I feel really happy. So I think from a spiritual point of view, psychoactives are very interesting things. From an actual kind of giving meaning to the physical world, well, not so much. Although I'm sure that some people who have dissolved themselves in psychoactives have gone on to make really interesting science discoveries. So Gary Mullis, I think his name, he's dead now, supposedly invented the concept of PCR when he was on an acid trip driving in California. And that technology gave the basis of the COVID detection systems we have now, and also the ability to manufacture DNA and RNA. So that was no poor thought experiment induced by a psychoactive substance.
That's that's very interesting. I didn't know that. I've only known that certain philosophers back in the day, like Walter Benjamin, wrote an entire thing about his use of hashish, and then certain postmodern thinkers like Foucault, Deleuze, and all of these people were also involved in these kind of psychoactive states, and they produced amazing philosophical texts. Getting inspiration from that. I mean, Sartre was known to have taken a lot of amphetamines and mescaline throughout his entire life. To a point where he even developed HPPD, which is like the hallucinations continue even after the trip has ended, and went to Jacques Lacan, who was this psychoanalyst at the time within the French circle, to get out of these hallucinations. So I feel like, philosophers and like even scientists to a certain extent have had these inclinations of taking psychoactive substances and getting upon a certain idea which is either revolutionary or makes sense to them. So it's very interesting how these compounds are actually functioning and what possibilities they could create. One last question I wanted to ask you was like, what are some of the books that you would recommend reading? Like, what are your personal books? Because I see a lot of books on your shelf, and I'm also an avid reader. So I was wondering what are like maybe 2 or 3 or maybe 5 books that you would recommend for everyone to read, like a must-read thing.
Must read. I don't really have that many must reads, to be honest. I'm not a. Well, I'm reading Stories of Our Life at the moment. Short stories from Ted Chiang. Just started reading that. Stories of Our Lives, I think it's called. And that's really interesting, but I've started at the big, picking my way through that. I do like Stanislav Lem. I just think if you really want to think in a kind of, in a different way, Stanislav Lem is really great science fiction writer. In terms of, I'm reading a lot of technical books at the moment. And I'm trying to read books that are crossing over ideas between different boundaries. So although I can tell you that although it's probably not the best book in the world, I did find some of Roger Penrose's initial writing, the Emperor's New Mind, although it's like so flawed in so many ways, I did find it, for me, when I was reading it at my poor level, whatever, was really interesting, and it got me going further. And of course, one of my favorite books was always kind of trying to look at rationality, again, through the pure, I'm not a very well-read philosopher. It was a kind of Robert Prissig's Zen and the Art of Motorcycle Maintenance. And I would recommend people reading that just from a kind of emotional point of view, of thinking about, the insanity of logic, because it can make you quite, crazy over time. But so I also like reading. So I'm reading a book right now, which is I've been reading it for years actually, which is just over here, which is a book by Charles Petzold called The Annotated Turing, which takes Turing's paper, this is this book here, and takes it apart. But there are certain, you should read some if people are interested in really deep digging in down and trying to question their own reality in a kind of practical sense. There are some philosophers you should read about in order, but it's probably worth asking a philosopher about that, because everyone has their own particular, avenue, and obviously some of the English philosophers aren't as well regarded as the German philosophers, right? And then going on. But yeah, so I mean, I actually find reading at the moment quite hard. It was only somewhat recently that I read Thomas Kuhn's Structures of Scientific Revolutions, because I got so annoyed with people telling me that revolutions in science didn't happen, and I wanted to work out why they were doing that. What was it? And it's this classic right wing, left wing kind of argument that we have in our human minds, where we're kind of all a community or we're all kind of libertarian, right? And there's no kind of central part. But what I would recommend, the number one thing to do, I would do, is I've done this in my academic life a lot, is try to go into areas, conferences, books I would read that I just wouldn't normally read, almost pick them out randomly. And okay, you don't want to go totally random, because you want to actually read something that is good and not just awful. But within a curated sense, if you could find something that would just take you away from your current zone, so you can make new connections, I think from an artistic point of view and a kind of searching point of view, that's the best advice I can give. So I try to read things. I mean, I wanted to read this book for years, right? But I just could never start it and finish it, which is book by Douglas Hofstadter called Gödel Shabak. And it is really an unreadable book. But the way I'm doing it is I pick it up and I will pick 3 pages at random, maybe 4 or 5 if it really, and just go through the book wearing it randomly. It's quite interesting doing that, because then you don't get bogged down in all the arguments. And sometimes that's worth doing when some books are written and they're monsters.
No, those recommendations are really good. Like something you said, Insanity of Logic could indeed be a book title someday, maybe that you could write.
Maybe there is a book called The Insanity of Logic, because one of the reasons why I like reading Gödel Shabak is this, he keeps saying this, there is this problem with recursion, right? We keep coming back. I think this is something that Sarah Walker expresses really well, who I think you've had on your podcast, where it says, the problem of having an equation of the God equation is that equation needs to be sufficiently descriptive to describe itself. But how can it be? So this human demanding for a conclusion is probably somewhat unhelpful, because all we're trying to demand is not a conclusion, not the answer, but to go one level up. I think going a level up is fine, but we're never going to get to the destination until we're at the end of the universe. So let's continue the journey and enjoy the next step, uncovering the next mystery and trying to answer it. I think that is the meaning, right?
No, very true, very true. That is indeed the meaning. Yeah, it's very interesting talking to you. I feel like I can ask like millions of questions like randomly, and always get an amazing answer. Thank you so much for coming on the podcast. It was really, really interesting. I'm going to revisit assembly theory and like really jot down everything and try to like be creative with it, and maybe also like maybe make something out of it and give it like send it to you and see what happens there.
Okay,
Because
do it.
it's very, very interesting to me. Because I feel like there could be parallels. Like I could take certain philosophical stuff and embed it. Because
Okay.
yeah, because Sartre talked about being a nothingness, where he tried to define existence by speculating what it means not to exist. So it's
Yeah.
a big book, and there's a lot of things there. But I feel like one could philosophically put assembly theory into function. I mean, I think that's
Yeah, I
probably
agree. Yeah.
yeah.
Cool.
So I feel like that's very interesting that could happen. But again, thank you so much for coming on the podcast.
Thank you. You're welcome. Really nice questions. Good to talk to you.
Yeah.